Chapter 5, Time Value of Money. So in this chapter, I'm going to introduce the concept of time value of money. The time value of money is an important concept in corporate finance. And in accounting, we use the time value of money to value the financial assets and liabilities. Because these financial assets and liabilities will generate either cash inflows and outflows in the future. And for many years, so the time value of money should be accounted for in the financial reporting. What is the time value of money? It means the money can be invested today and earn interest and grow to a larger amount in the future. So here, if we assume the annual yield or interest rate 6%, if you invest $100 now, and you will have 106 1 year later. So these two amounts, mathematically, they are not equal. 106 is greater than 100, but they are equivalent in terms of the time value of money. In other words, if the future value is 106, under assumption the interest rate 6%, its value at current is $100. Or the $100 now, its future value will be 106 under assumption of 6% annual yield or interest rate. So if we consider the time value of money, the $100 present value, it equals the future value 106. Even these two numbers are not equal, because the time value of money is significant during a long time period. So we should not ignore it when we value the assets and the liabilities. The time value of money as a tool, we can convert the money from future to calculate its present value. And also, if we have the value of money at current, under the assumption of interest rate, we can calculate its future value. So the time value of money actually is the interest. The great time value of money means the great interest. To account for the time value of money, we should know the different concepts of interest. So there's two interests. One is simple, the other is compound interest. The simple interest is calculated using this formula. The initial investment or the principal, multiply the interest rate, and multiply the time. And for the simple interest, the principal does not change, or the interest will not be reinvested or become part of the principal. Well, compound interest is different. So the principal not only includes the initial investment, it also includes the accumulated interest earned in the previous periods. In other words, for compound interest, we assume the interest will be reinvested and will become part of the principal. So the follow-up interest actually not just generated from prior initial investment, but also from the previously earned interest. So in a simple word, compound interest assumes interest can generate interest. So let me introduce some examples. For the simple interest, we assume the initial investment, 1,000, interest rate 10%, one period, so interest will be $100. And in the second year, again, 1,000 does not change because $100 interest will not be reinvested. So the second year, the interest is still $100. For compounding interest, the interest will become the principal in the next period. For example, in the first year, the interest is $100. And by the end of the first year, the $100 interest will become the principal in the next period. So starting from the second year, the principal starts from $1,100, which includes the initial investment plus the interest earned in year one. And then multiply the same interest rate for the second year, so the interest grows from 100 to 110. So finally, the ending value will be 1,100 plus 110, so 1,210. So here, the difference in the interest 10 actually is earned from prior interest multiply interest rate. So that's what I said. The interest will generate interest. In the third year, 1,210 will become the principal at the beginning of year 3. It will generate more interest than the second year. So you will see the compound interest will generate higher interest than the simple interest. And the compound interest is commonly used in corporate finance and in the capital markets. The reason is interest is also money, so interest has time value of money. In this chapter or in the financial accounting, when we talk about time value of money, we assume we are using the compound interest. Usually for any given problem, you're given an interest rate. The interest rate actually is annual rate or actual rate per year, assuming the annual rate 12%. And depends on how frequent the interest are compounded. In other words, how frequent the interest will become principal. So for different problems, we need to consider the frequency of compounding or the compounding periods. If the interest is compounded annually, so the interest for this period is just annual interest rate because each period is a year. If the interest is compounded semi-annually, in other words, interest compounded 2 times a year. Okay, so the interest per period will be divided by 2, 6%. So the interest will be compounded in this way. In the first half year, 1 multiply 6%. And then in the second half year, it will be 1.6% square. If the interest is compounded 4 times a year, that's compounding quarterly. So the annual interest will be divided by 4. So each period or each quarter, the compounding interest will be 3%. Similarly, it will be 1 plus 3% for each period. So 4 periods, so this is the rate for 1 year if compounded quarterly. So on and so forth for 1 year, that will be 1 plus 1%, 12. And you will find compounding for the same annual rate, compounding monthly will result in greater value than the compounding quarterly, will be greater than the compounded semi-annually, will be greater than the interest if compounded annually. The reason is the more frequent the interest compounded, that means the earned interest will become principal and generate interest more frequently or earlier. And so when you have any problems and questioned in this chapter, you should read the question carefully and learn how the interests are compounded. And so here, the example assume the initial investment 1,000, 10%, it is annual rate, compounded twice or semi-annually. So what will be the investment by the end of year? So because interest is compounded semi-annually, so each half year the interest is accumulated at this rate. And next half year will be another 5%. So it is 1 plus 5% squared. The value at the end of year 1 will be 1,000 multiply this. The value will be $1,102.50. And this just shows the detailed process how the interests are compounded and accumulate. In the first half year, it generates 5%, which is half of annual rate. So it generates $50 interest. The principal become 1,000 plus 50. Then 1,050 will become the principal at the beginning of the second half year. Again, accumulate 5%. So interest in the second half will be 52 and 50 cents. So the ending value at the end of year 1 will be $1,102.50, which is different from the simple interest by using the principal multiply the 10%. So it's 1,100. So the $2.50 difference represents the interest earned from the first interest. Also, you can calculate using the total interest divided by the initial investments. The interest rate or effective interest rate will be 10.25%, which just equals to what I circled. And it is greater than 10%. Let's try these multiple choice questions. First, 600 is the initial investment. Interest rate 8%. This is annual rate. Compounded twice. What's the investment at the end of the first year? So to calculate, you just use principal multiply the effective interest rate for 1 year compounded twice. So it should be 8% divided by 2, that's 4%, and square. So finally, you should get $649.